So, hello again. Tonight we're going to talk about this is a simple, maybe clickbaity type of topic: human communication foibles. Or basically, I watch a lot of YouTube videos, and I have some issues. So, this is me admitting what you might already know. I watch too many videos, most of them on YouTube with ads. I skip them if I can. I'm curious about things that most people are not. A laundry list of things there. I am very appreciative of the empowerment that I have from my formal and parental education and self-taught stuff, plus my career experiences, all of which gives me access to a vocabulary and some experience that allows me to uptake new and different things easier, but no genius here. I'm still doing all the homework necessary to learn what I didn't learn when I was born. So, as I said, I watch lots of videos. My preference is videos that get right to the point, although most videos nowadays don't. Majority of folks on YouTube monetize their channel. That means that they conform to a certain content. They keep it to a certain length and things like that to get revenue from YouTube. And it's not much per view, but when you have millions of subscribers, it can be thousands of dollars per month. Broward Astronomy does not currently monetize its channel. I think of it as our content is so esoteric and deep science that I'm not expecting thousands to millions of people to watch and subscribe, although I still put in the base of the presentation the subscribe, like, and all that kinds of stuff. And then we do have a Patreon account. It's more about getting information out there that I don't see either existing or doesn't go to the same level of detail to explain things in case people are curious. I do have teaser titles that, I've often done a part one, merely the beginning, tune in for part two. Not always, but on occasion. I watch one guy, he, calls it as he sees it, and he'll pick some topic and he'll actually let you know, okay, we've just gotten to 3 minutes and now I need to make it a little longer in order to maximize the assurance of revenue for this video. And then he ends it at less than 8 minutes because that's the way the algorithm wants to see it. So I watch a lot of other folks do videos. They'll do less than 2 minutes on a topic kind of as a teaser, and then they'll solicit for you to like and subscribe, or they have a Patreon or whatever, buy me coffee or whatever they're using to get some money in. And then they do a paid sponsor announcement embedded in their video, which YouTube can't really do anything about that. But some of these sponsors pay thousands of dollars per video to sponsor specific content. And then after that ad, YouTube will throw in their own ads for their own sponsors. And then you can finally get back to the content where the author bleeds out, extending it to make the video long enough, and you listen to it for long enough, and then you realize towards the end of the video, about 2 minutes before the end of the video, is that all you wanted to say? You could have said that in 1 minute, but then he adds filler of summary and conclusion, which I change my conclusions to summaries because it's more honest that way. At the end of the video, to achieve the desired duration for his monetization. Like, okay, I get it. That's just how things are, and I'm accustomed to it. But it's just them doing business. But I can skip through things if I want to. I've actually been known to watch certain videos where the author drags things out by speaking slowly, and I'll just change the slider to, okay, show me the video at 1.5 or 1 3/4 or 2x speed. Some people are slow enough that I can actually uptake it at 2x, which is fast, but still understandable. So when they talk about straws and camel's backs, I watched a video today. It was the most drawn out thing I've ever seen on YouTube. And all they wanted to do was describe that there's a unique trait in computers that use something called an exclusive OR instruction, that instead of, if you want to change, if you want to swap the value between two memory locations, A and B, that if you set up a temporary location C, move A to C, move B to A, move C to B. Done. No. If you take the original values and you XOR them, and then you take the result that was XORed and you XOR it with the original value, with a modified value, you've literally flipped all the individual bits between the two values, and you don't need that extra storage location. The concept was you're trading space, that extra storage location, where you only need one instruction, because they do make complex instructions, versus time and space where you take longer to execute, but you don't need that extra storage space, right? Okay, but that was just the one that just they even felt like they needed to drag in Turing machines to bring the point home. My thought was it's about as frustrating as somebody in high school taking pre-calculus and learning about derivatives by successive approximation for an entire days of class and then exercises and knowing how to do it. And then the very next class day, they just show you, here's the shortcut way of doing derivatives. Okay. It's not good to think about doing harm to your teachers, but you think it's all over. And then later on in the same pre-calculus course, they drag you through the same mud regarding integrals, which is just formula area under a curve beginning to end. Okay. Is it really so hard for people to be able to connect dots without all this background stuff? It's not minutia. It's not technical details. It's we're just dragging the video out as opposed to just telling you, by the way, here's how you do it. There's a guy that does math problems on YouTube. It's just little chalkboard math problems. You can see the answer very shortly into the video and come up with the answer yourself without going through a lot of the math because I took high school algebra. So maybe I'm watching videos that are meant for people that haven't even taken high school algebra yet. And that's okay. That's fine. Some of these videos don't need the unrequired details. I worked through the last couple of weeks trying to set up a STEM project for a teacher to do hydrogen line, 21 centimeter radio astronomy observing using a do-it-yourself home-built pyramidal horn antenna. I had to watch too many videos to achieve a simple, practical end result. The videos were all over the map. They dragged you through unneeded history. If every time somebody was going to be taught how to drive a vehicle, they started with the invention of the wheel, it would get boring very, very quickly. They went through the physics minutia of electron spin, and it's now not really a spin, it's an angular momentum. Okay, I just want to build a radio astronomy antenna here. It does what it does. The fact that I know how spin works isn't going to change spin. One person was very proud that they were going to announce how many billions of hydrogen atoms were spin flipping at any point in time. Okay, as long as it's a large number, I don't think people are going to be generally interested in that, but okay. But when they talk about the 21 centimeter hydrogen line, 2 digits of precision is all that they were specifying. When if you're going to tune your radio receiver, your do-it-yourself radio receiver, you need probably 4 or 5 digits to get an accurate center line on the wave. But okay, they were approximating, but approximation doesn't work to get a good result. And they're talking about all kinds of antennas. Okay, the simplest one is a wire, a dipole, but that's not good enough. So you build a horn antenna out of, air conditioning duct and aluminum foil and tape. And okay, that's fine. But then they go into talking about giant radio dishes and, the dish that cost them several $1,000s buying it used on eBay. And like, just show me the cheap one that most people can afford. I don't need to be, shown your ostentatious mounted antenna. And then antenna functions. Okay, here's where the radio comes in. Here's how it gets funneled. Here's the element, and then it comes out here, and that's where you connect your radio. Okay, comes in here, goes out there. That's pretty much all you need to know. It does what it does. And then they'll very quickly show you the end result in a window, not Microsoft Windows, but just some window of some random app showing a spike, like a peak in the middle. And that's just the frequency itself. That's not actually the broadband hydrogen that you need to look at things like the rotation of the Milky Way galaxy, showing red shift, blue shift, Doppler shift. And then they show you the end result in a window of some application. They don't even tell you what application's running. Okay, I don't need all this stuff. Imagine if you said, I'd like some toast with my breakfast. You go buy a toaster, you hook it up, you make toast with bread. That's the same thing here. You don't need all of this other stuff if you're really just trying to receive the hydrogen line and show it on a computer screen so some students can see it. So the things that are needed but not communicated, first up, a lot of people use mobile phone apps nowadays. Let them know right up front, this is not meant for mobile phone apps. Maybe tablets, but certainly not mobile phone apps. It's just too resource intensive to do that. And then, like, what are you going to use for your receiver? Well, you could use a $20 little USB device, but that's not going to be temperature stable enough for practical use. Well, you can buy a little $40 USB device. That's very usable. Or you can use what some guy bought because he's got more money and he bought a $130 receiver. Great for him, but not really necessary to demonstrate it. Or you can get the guy that's really an electrical engineer. He spent $400 and then he assembled the receiver himself. And okay, that's not the people that this is supposed to be targeted at. And then once you have your receiver, what software do you run? Well, as soon as they say you're going to be running SDR sharp, SDR pound sign, running SDR sharp, well, that kind of commits you to Microsoft Windows and the latest version of SDR sharp if you want to do this without failures. It also commits you to using a plugin to that called IF Average, and they fixed a bug in it this year, so you need the 2025 version to make it work properly. But what it does mean is you're not going to take raw data, like the actual sample streaming out from SDR sharp, because you can't do anything with that directly. And it also means, oh, well, it's Windows only, so you're not going to be running this on your Apple Macintosh or your Linux system. But the flip side of that is some guy just started saying, I use Virgo, which is an app that does hydrogen line condensing and displaying. And he doesn't mention, oh, by the way, that will mean we're running Linux. And if you live in a world that's populated by Windows, the majority of the world, then you've got a learning curve, a whole new operating system and software. And he just failed to mention that. And then once you've said it's going to be Linux or Windows, like in the case of Linux, is it Ubuntu? Is it Raspbian? Is it the Raspberry Pi packaged version of Raspbian? Tell us that. It would help to know that up front, because if you've got the wrong version, it won't run right. How about Windows? There are a lot of people, sad to say, that are still running older versions of Windows. And if you want to be running the latest version of SDR Sharp, kind of Windows 11 is where it runs, but they need to say that. Or you've got libraries that are under the operating system that the application requires. OpenGL, .NET, whatever your graphical user interface is. If you're on Linux, does it need X Windows or not? They don't mention that. You're just on your own. And then, okay, I've got my USB dongle that's my receiver. Where do I get the drivers from? Because the operating system needs drivers to talk to the hardware. And is it using the default driver? Well, operating systems generally think these little dongles are TV receivers. So they bring in the TV driver. And that's not what you want. You want the bulk USB driver. Under Windows, it's pretty straightforward. There's this thing called Zadig that you can download that software, and then that software will give you the right drivers. But they need to mention that. How do you get a cable to your computer? You bought a brand new computer. It's only got USB-C. I'm sorry, the receiver device uses an older USB connection. And the cable that you have is terminated with micro USB. How do you plug it in? You got a problem with goes intas and goes outas. Do you really need a low noise amplifier to get this to work? If so, what kind of filters does it need? How do you power that? Sometimes you can do a bias T and it'll power it in line. Sometimes you need an external power cable. They don't mention stuff like that. Or if you're in a radio frequency noisy environment, or you've got a laptop that has a lot of RF noise in it, that can essentially run over the USB cable and go out to your receiver and pollute your received signal. How do you deal with that? What is an RF choke? How do you get one of those on Amazon and clip it onto the wire? They don't cover that. They just leave you to deal with the noise. And then there's a whole universe of other things that they don't tell you that are settings. These applications, these routines, they have a lot of parameters, and the defaults aren't meant for hydrogen line receiving. They're meant for other radio astronomy or other radio purposes. The same software can be used to tune an FM radio station, and then you change a bunch of the parameters and look, you can do hydrogen line. So they don't mention things like how fast should you sample the data? How much is the data dynamically changing? So you have to sample it at twice that rate in order to get the data. That's the Nyquist, Shannon Nyquist. What's the samples per second rate? How wide, how much, how many hertz or megahertz of bandwidth do you need to pick up the center of the galaxy and then the arms of the galaxy, the Doppler shifted arms of the galaxy? Or is it just the center line? Because the center line is just like one peak. That's not that interesting. Look, I've got the hydrogen line. But the interesting thing is the galaxy rotation. What's the modulation? Because by default, it's going to be set up for like FM radio, but you're receiving natural signals, not man-made signals. So you want exactly as you receive it. You want it raw. Should it automatically adjust the gain on the receiver? And that's a thing called automatic gain control, or AGC. And you don't want to do that with natural signals. You want to just amplify it to a certain level so that it brings the signal up. Done. How do you switch on the power for your low noise amplifier if you're not using an external power cable? There's a checkbox you have to set, otherwise you get no signal. Now that you're receiving the signal and you're seeing things moving around on the frequency spectrum, now what do you do with it? Well, that's just the raw data. You have to integrate the data. You have to take samples and then average them to get rid of background noise, and then you have to combine them to make the graph that is the pretty picture that you really want to get. So you need to know about those things and how to set the parameters for that, how many samples per second to integrate over how much time, how much digital amplification to boost the signal, the level below which you don't want signal, so that's bottom clipping. How many samples are you going to put in an output file? Not just one sample. You might want to put, 256 in a single file. And how many files? How long are you going to be observing this? The longer you observe it, the better the set of data you have, but you need to condense that down. So how many files you can output? I did 100 files easily, and I said, maybe that's enough. So I had it spit out 1,000 files. Where are you going to store the files? Because that might take megabytes. You need to identify the path to where the files are going to be stored. And then because all the file names can't be the same, they've got to be sequenced. You might want to put a prefix on that. Like if you're using IF average, I use IFA, and then it puts out underscore and then 4 digits of sequence number for the files. So that way you can go find the files and do something with them. But now you've got halfway processed data, no pretty picture yet. You need to do some back-end processing. You have a folder filled with your averaged files. What's in those files? What can consume the content that's in those files in that format? If you're running a specific kind of program that will take the data and make the pretty picture, the Gazinta has to match the expected Gazouta. So if you're using, for example, on Linux Virgo, then it expects the data format to be what the GNU Radio spits out, not what SDR Sharp would spit out. But if you're running something on the back end in a Windows environment like Excel to make a chart, or if you have the license and pay the money, MATLAB, you can do that. Or if you're going to write some Python stuff to do it yourself, Plotlib, you have to know what the input file looks like. The back-end processing, no pretty picture until you've got the back-end processing. But they kind of skip over that. So as the saying goes, ignore the man behind the curtain. It's bad enough that they don't tell you what you need. But even worse than that is they'll show you a graphic of the waveform for the hydrogen line, and there'll be some like extra noise spike sitting off on the side doing something. And to somebody who doesn't know any better, they'll think, oh, that's part of the hydrogen. It's like the active hydrogen. No, he's got somebody with a bad radio transmitter in his neighborhood and it's producing a spike. And he never mentioned that that's noise and you should get rid of that. Don't worry about it. Do not expect to have that in your signal. Okay. They'll just show you the raw data, like wiggling a little bit, but they won't show you what's it supposed to look like. It's just supposed to look like random little things moving up and down, but you have to process it because that's the raw data. The actual thing that you're looking for looks like something that has 3 humps on it. So the intermediate averaged signal is not wiggling data like this because the average brings it down to something steady. And you'll see a hump, a little dip, a bigger hump, a dip, and then another smaller hump. And what that is the rotation of the Milky Way galaxy and the frequencies that are going away from you, the frequencies that are coming towards you. That's why they're shifted out wide. And then the bulge in the center is around the hydrogen line. But even the bulge in the center of the galaxy is rotating slightly. So the three humps is what you're looking for. They'll show you that. They'll not tell you that's what you're trying to achieve with the intermediate data is the three humps. Don't skip the steps. Show us how you got there. Show us what you do with it. But they just go this, then this, then this. Done. Here's your picture. Okay, so they can connect the dots because they're very experienced with it, but somebody just starting out won't. So how about some help here? So, okay, I went off on a rant, but it's based upon my recent personal experiences, so apologies for that. I am somebody that can complain because I create YouTube content and I can, from a scientific perspective, spot how to improve things, to make them more accountable to their audiences, to give them better results. You should pay attention to what it's going to cost the people that are trying to duplicate what you're doing. If all of a sudden they go, oh, I'm a Windows person, I should learn Linux. You've just taken them down a giant rat hole of not only learning, reproducing, but maybe have to buy a whole new computer because they don't want to lose their Windows computer. Well, nothing, no skin off the content author's back, but that person that they thought they were going to be pretty successful at doing this just went down a rabbit hole. I think when a content creator does something like that and sends somebody down the rat hole or has unexpected expenses or learning curves, point that out. Go in the comment section, point that out. It's better to explain things rather than skip over them. Second thing is take your pains and your scars and use them to improve your efforts for those just starting out down the path. To quote the late, great, enough said. But I did bring some links. So somebody probably went, what's a foible? There's your dictionary definition of what a foible is. And then the very lengthy presentation just to explain how a computer XOR instruction works. I've got the video if you want to go through that. What's a Turing machine? And I purposefully misspelled Turing so people would notice. Like, Turing machine, like we're going somewhere. No, it's Alan Turing. And then what is hydrogen line, the 21 centimeter thing? And note that I put little approximations there because that's not actually the number, but if you go to the Wikipedia page on hydrogen line, you can see that it goes out many decimal digits. And then basically a video showing you the graphical windows of the various jump steps to step to step of somebody doing hydrogen line observing. And all they did was they played music in the background and didn't explain anything, but it's a short video to watch. Okay, so that was a presentation meant for the people that are going to consume it on YouTube, not so much for the Broward Astronomy members, but if anybody has any questions, doing hydrogen line observing is not that difficult. It's pretty straightforward as long as you cover all the steps. But if you jump across steps, it can be something you will not be successful at. But like I said, this was really for the public YouTube channel more so than tonight's audience. Okay, I'm going to stop recording now.